Today we're going to cover tangents in Lesson 10.5. A tangent is a line that intersects a circle in exactly one point. So in our diagram here, line AB intersects circle C in exactly one point, and that's point A, and that's called the point of tangency. So we can say that AB is tangent to circle C at point A. A common tangent is a line, array, or a segment that intersects two circles at exactly one point per circle. So in the first diagram, line L intersects circle G and circle F, each of them at exactly one point. In the second diagram, circle F and circle G have a point in common, and line L goes through that point, and so it is also tangent to both F and G. The next one, we can tell if a line is tangent to a circle if and only if it's perpendicular to the radius at the point where it intersects the circle. So in this picture, line L is perpendicular to ST, so therefore L is tangent to circle S. The other way around, if we know that ST and line L is tangent to circle S, then we know this angle has to be a right angle. In the next diagram here, we have two tangents, AB and CB. They both intersect outside of the circle at point B. So since that happens, we know that AB is congruent to BC. So we know that AB is congruent to BC. So let's look at common tangents. In the first diagram, are there any common tangents? Are there places that we can intersect a circle, like we can intersect this inside circle at one point, but it intersects the outside circle at 2 points? If I intersect the outside circle at exactly 1 point, it will never intersect the concentric circle. So the answer here is no. They have no common tangents. In the second diagram, I can draw a tangent that intersects the two circles this way, and I can draw another tangent that intersects the two circles this way. So this one, yes, it has common tangents, and it has two. In the next picture, once again, I can intersect this way, I can intersect this way, but I can also have a common tangent that goes like this and like this. So this one's yes, it has 4 common tangents. And number 4, does it have common tangents? We know from previous that these two circles intersect at one place, so we have the tangent that goes this way. We also have one that goes this way. Oops, I drew it with 2 intersection points, sorry. This way and this way. So this picture here has 3 tangents. Here we want to determine whether LM is tangent to circle K. To determine that, we have to show here that angle L is a right angle. So to do that, we use the Pythagorean theorem. Is the hypotenuse, which is 29, so 29 squared, does it equal 20 squared plus 21 squared? Well, 29 squared is 841. Does that equal 20 squared, which is 400? And 21 squared is 441. That does equal each other. 841 equals 841. So yes, LM is tangent. to circle K. And this right here is our justification. That's what you would have to show to justify that answer. And the next one, we're told that WE is tangent to circle D at W. So we know that this has to be perpendicular, because if it's tangent, it forms a right angle with the radius. So we know this whole side right here is 16 plus x. So to do the Pythagorean theorem, we would do x squared plus 24 squared equals 16 plus x squared. So x squared plus 576. Now 16 plus x squared, or x plus 16 squared, is x plus 16 times x plus 16, which give us x squared plus 16x plus 16x plus 16 squared is 256. So x squared plus 32x plus 256. Both sides have an x squared on either, so if I subtract x squared from both sides, that goes away. If I subtract 256 from both sides, I have 320 equals 32x. So x would equal 10. And the next problem, we're told that AC and BC are tangent to circle Z. That means that these two, AC and BC, would be congruent. So AC equals BC. So 3x plus 2 equals 4x minus 3. Subtract 3x from both sides, I would have x. Add 3 to both sides, I have 5. So x equals 5. For the final problem, we have that round cookies, which is circle T here, are marketed in a triangular package. So we know that, or told that, QRST is circumscribed about circle T, and we want to find the perimeter of QS. Well, first of all, we know that QN and QL have to be congruent because they're both tangent. So the length of QL here would be 2, which leaves the length of LR as 6. LR and RM are both tangent to circle T, so MR also has to be 6. SM and SN are tangent to circle T, so SN also has to be 10. So to find the perimeter, I have two 10s, so 210, 2 times 10, plus 2 times 2, plus 2 times 6 would give me the perimeter. So the perimeter is 20 plus 4 plus 12. So the perimeter would be 36 centimeters. And that concludes the lesson for 10.5.